Hello, everyone. So this is the very first real lesson of Soc 301 for the semester. Before you started watching this, you should have done two things so far. So the first is that you should have read Salkind textbook chapter 1. And the second is that you should make sure that you have out the chapter 1 lesson outline. That this is essentially an outline with the missing blanks and spaces of the lesson we're about to go through. So take a pause. If you haven't read yet, read first. It's going to make things easier on you. And then second, make sure that you have the lesson outline either printed out or at least up open on your computer so you can be typing into it as we go along. For some of the lesson outlines, it's going to be more helpful to probably have it printed out if you have access to a printer. For today's, there's not much that we're doing like calculations by hand or writing down formulas, etc. So it's not so important for this one that you have it printed out. Other lesson outlines more important for you to print out, and I'll let you know as those come up. Definitely the next few for chapter 2 and chapter 3. Try to get those printed if possible. Okay, so without further ado, let's jump into the fun here. So this chapter is called Statistics or Statistics, if I can say that correctly. And so we're gonna kind of start with some really helpful big picture lingo first. Let me make sure that my little face is not covering the important information on the screen. There we go. Okay, so in terms of data, we can think about there's multiple forms of data or information. A data point is a singular piece of information, whereas data are plural, or a data set are a group of data points. So a data point is any observation or measurement. So for example, an observation could be, I want to study how often students pull their cell phones out during class time. And I sit at the edge of the room and I count every time a student pulls their cell phone out. Each piece of that information is a data point. Every time somebody pulls a cell phone out, that's a data point. Measurement could be anything that's on a survey, right? So we did, many of you, thank you for doing the class survey. One of the class survey questions was, what's your gender? For each person who replied with their gender, that person's answer is a data point. Other examples include, one student visited 8 states. That's from our class survey as well. So a data point is singular, is a single piece of information, either from an observation or some type of measurement. Data are plural, also known as a data set. So anytime you have a grouping of multiple data points, that is called data or a data set. So for example, if we looked in our class survey at all of the students' information on states, and we would say something like, the average number of states visited is 7, or all of the students' info on gender. This is a very female-heavy class that we would be able to say the majority of students in this class are female. Those are examples of data from our data set. Statistics, what do we mean when we say statistics? So statistics are a set of tools and techniques used to describe, organize, and interpret information or data. In other words, how do we use numbers to summarize some type of social phenomenon? What are some examples of statistics? Test scores. If you want to know what's the lowest test grade in a class and the highest test grade or the average test grade, those are all examples of statistics. A sports example could be, what's the number of errors in a baseball game? If there's, for a given game, is the number of errors greater than or less than, on average, how many errors a team has over the course of the season? Perhaps the average price of a dinner at a restaurant. Is the restaurant more pricey or less pricey? If you're looking up a restaurant on Google and it shows, the little dollar signs next to the restaurant name, some restaurants have $1 sign, meaning it's really cheap. Others have $4 or $5 signs, meaning it's really expensive. That's an example of a statistic, right? We're using some type of technique to summarize information about a phenomenon. We know then that data can be collected, organized, summarized, and then based off of those summaries, those data are interpreted. And that's what statistics is all about. Okay, next thing is statistics fall into two different categories. The first is called descriptive statistics, and the second is called inferential statistics. So for the sociology and criminal justice majors in the class, you know that you're required to take this first statistics class 301, and then next semester in the spring, you take 302, the second statistics class. This class this semester, 301, is largely about descriptive statistics, and then 302 covers inferential statistics. We'll cover this semester kind of some of the theoretical bases of inferential statistics, but all of the actual doing of that work comes in 302. So what's the difference between these? Descriptive statistics are techniques and tools that are used to organize and describe data. So one way to think about descriptive statistics is, how can we use numbers to best summarize a whole set of numbers or a whole set of observations or measurements for social phenomenon, right? How can we pick perhaps one value that best represents all of the values in a data set? How can we pick a value that describes how spread out different values are? And that's what descriptive statistics is all about. So for example, we could say, looking at our student survey, the most popular sports team is whatever, right? I think it turns out to be the Eagles for this group. I can't remember. Looking at our student survey, the average amount of money spent on a night out is $50. So descriptive statistics are taking data that we already have and trying to summarize those data that we already have. In contrast, inferential statistics take data that we already have and use those data to make some type of inference or assumption or guess or estimate about a population we don't have data on. So inferential statistics are different from descriptive statistics because they're looking at a set of data and saying, how can we use these data that we do have to make some type of conclusion or estimate about some larger group for which we don't have data. So this really is important to understand the differences between a sample and a population in order to understand what inferential statistics try to do. So a sample is a subset of the overall population. A sample is, we have information on this group of people, on this neighborhood, on this part of the planet, whatever. And then a population is everything that you're interested in studying, right? So this is all possible subjects or cases of interest. Our class survey may be a subsample, maybe a sample of all LaSalle students or a sample of all university students, perhaps. And so what this is doing is saying, do we have information about everybody that we want to draw conclusions about? That everybody we want to draw conclusions about is our population? Or do we just have information on a sample of people? Political polling is a helpful example here, right? So if we're thinking about the upcoming presidential election, we'll see lots in coming months about pollsters asking people are trying to make predictions about who's going to win the presidential election. It's obviously impossible to survey every single likely voter in the United States. So instead, we'll take a sample of voters, a smaller group of voters, and ask them who they're likely to vote for, and use the data we have on that sample to make a conclusion or an estimate about the larger population, about the whole country. So that this is an example of using inferential statistics because our population of interest does not include everybody that we can possibly survey, right? So that we need to be able to use a sample. And if we think about another example for inferential statistics, we can ask ourselves, are there certain questions on our class survey that would be representative of, let's say, all LaSalle students or all university students? Or are there questions which shouldn't be used to make inferences about the university population, and why? So that there will be time later in the semester where we'll talk more about this idea when we're getting into inferential statistics about, does the sample represent the population, right? So for example, this first question here about, are there survey items? Remember, our survey can be thought of as our sample because we have data on everybody that's included, everybody who's surveyed. Are there items on that survey that we think could be used to make inferences about the whole population of LaSalle University? Some we probably could, right? Perhaps the number of states visited, or the number of, or somebody's mother's highest level of education. There's no real reason to think that those answers for our class would necessarily be a lot different than for LaSalle University as a whole, right? So in those ways, the answers for our survey, our sample, are probably representative of the population. However, we can ask then, are there questions on our survey which we think shouldn't be used or wouldn't be appropriate to use to make inferences about the whole university population? And what would those be and why? I would say primary major is probably one of the most important ones, right? Or academic class is a big one. We know that people tend to take this class when they're juniors, sometimes when they're seniors. But can we be able to say, 80% of LaSalle students are juniors just because in our class survey, 80% of students are juniors? No, that wouldn't make sense, right? For that question, our sample would not be representative of our population. So in sum, inferential statistics is all about taking information about a sample and using it to draw conclusions about a larger population. So I gave the political polling example. Pharmaceutical testing, drug tests are another example of this. So if a pharmaceutical company is trying to figure out whether or not a new medicine, I don't know, reduces blood pressure, is it possible for them to test this drug on every single person who has high blood pressure? Of course not. They take a sample of people who have high blood pressure and give them the drug. And if it works with this sample of people, then they expect or make an inference or an estimate that it's also going to work with a larger population of people who also have high blood pressure. Okay, so summary here. Thinking about descriptive statistics are when you are using numbers to summarize data that you actually have, right? We're not trying to make inferences or guesses about something else. Descriptive statistics is we're using numbers to draw conclusions, make observations about data that we actually have. Inferential statistics are used when we have a population of interest, a population that we want to study or draw conclusions about that we can't possibly investigate or observe or measure every single person or thing in that population. And thus we need to use a sample, a smaller part of that population, in order to study the population. So as you're thinking about the answers to these questions, ask yourself the kind of helpful steps to go through are: one, do we have information on everybody that we want to study or draw conclusions about? If the answer is yes, then it's descriptive statistics. If the answer is no, we don't have information on everyone we want to study and we need to use a sample, then your answer would be inferential statistics. Okay, so we can go through these. It might be helpful for you to pause here and read these through and ask yourself, take a guess for each one if you think it's descriptive or inferential. So feel free to do that, do a little pause. Okay, so hopefully you took a minute and wrote down descriptive or inferential for each of these. This first one is, what's the average final exam grade in Caitlin's statistics course? So if we go through and ask ourselves the question, is it possible to have data on every person or thing in the population of interest? The answer to this is yes, right? We can know the final exam grade for everyone in my statistics class. So that means this would be descriptive statistics. Because we don't need to take a sample to draw a conclusion, we have data on everyone that we want to study, then it would be descriptive statistics. The second one, what is the most popular beverage enjoyed by LaSalle students? Here, this one would be inferential statistics. You ask yourself the first question, is it feasible or possible or likely to be able to get data on everyone we want to study? Here we want to study all LaSalle students. Is it possible to really survey all LaSalle students about their favorite beverage? Probably not, right? We would need to, in order to do this, we would take a sample of LaSalle students and ask what their favorite beverage is, and then use that to make a conclusion or draw an inference about our population of interest. So the second one is inferential statistics. Third one, which LaSalle soccer player has the highest number of assists per game? Here, this one is descriptive, right? It's possible for us to have data on everybody we want to study, right? We have information on the assists per game for every soccer player. We don't need to take just a sample of them in order to study it. So this one is descriptive. Fourth one, do prison education programs reduce reoffending for inmates, for people incarcerated? This one would be inferential. Is it possible or feasible or likely to have data on absolutely everyone we want to study, on every of the 2.3 million people incarcerated in the United States? Probably not. We would take a sample of people incarcerated and study whether or not prison education programs reduce reoffending for them, and then use that information to extrapolate, to expand out to the population of interest. So when determining descriptive or inferential, first and most important question to ask yourself is it possible or feasible or likely to have data, to collect data on every person or thing we're trying to study? If the answer is yes, then it's descriptive. If it's no, and we need to take a sample, then it's inferential. Okay, so more practice to come on doing that in the classroom. The last part of this descriptive and inferential part is the text uses, I think, a really helpful term here, which is garbage in, garbage out. So take a minute and ask yourself, what do you think this means in the context of descriptive and inferential statistics? So, and if you have your textbook open, feel free to go back and read this part at the end of the chapter on garbage in, garbage out. So what I think this is saying is the importance of good data, right? So that especially when it comes to doing inferential statistics and making conclusions about from a sample to a population, it's only helpful if the data you collect are valid and reliable. Same thing goes for descriptive statistics. If, for example, I wanted to ask the research question, what is, what percentage of students in Caitlin's fall 2020 statistics class live in a dorm on campus? That's one of the questions from your class survey, right? But perhaps for the class survey, over half of you didn't even read the questions and you just went through on Qualtrics and clicked random boxes because you were trying to hurry up and get it done and you didn't really care about it. Would whatever conclusion I make about that research question about the percentage of students who live on or off campus, would that be a helpful conclusion if so many people didn't input good data? Of course not, right? So if we're inputting bad data or garbage data, then any conclusions we get out of it are also going to be not helpful and garbage conclusions. Okay. So this is finishing up the first part on descriptive and inferential statistics. As a little extra practice for yourself, getting you to start thinking about processing this, I would encourage you to take a minute and write a research question. So think of anything you might want to study, and then decide if it would be descriptive or inferential and explain why. And so when you're doing this, think about something you'd want to study as your research question, and then ask yourself, is it feasible or likely to collect data on every single person or thing that I want to study? If yes, then it would be descriptive. If no, and you would need to collect a sample and then draw conclusions about that sample to the wider population, then it would be inferential. So feel free to pause if you want to do that little extra practice activity to get this rolling in your brain. There will be other practice in the classwork as well. Okay, so that concludes the descriptive and inferential statistics part. Second part of this chapter is on variables. And this is also, I should have said in the beginning too, you're not just reading chapter 1 here, you're reading those additional pages, which I'm blanking on and don't have the syllabus out in front of me, but as in the syllabus as the assigned reading. I don't know why they talk about variables in chapter 1 without also doing the levels of the scales of measurement part in chapter 1 is one of my only real complaints about this textbook, but so we read it a little funky out of order. Okay, so this is really critical for the rest of this class, is being able to think about, for any given variable, how is it measured and what does it represent? So starting at the very beginning, what do we even mean when we say a variable? A variable is any attribute or summary that describes a person, place, thing, idea. A variable can be anything. The reason that we call it a variable is because the value of that thing can vary from one entity to another. So you can ask yourself, what are some examples of variables we've talked about so far? And essentially anything that was on our class survey is a variable. Gender is a variable. It can vary from one person to the next. One person might be male, one person might be female, one person might be trans. Another example from the survey could be your political affiliation, right? Political affiliation is a variable. Somebody might identify as extremely liberal. Somebody might identify as extremely conservative. These are things that change or vary from one person to another. So a variable can be pretty much anything. I'm checking my notes here, make sure there's nothing else that I want to be telling you from these first slides that I'm forgetting. Okay. I think we're good. Okay, so this next part is really key. So scales of measurement. So for every variable, there's different levels at which these variables are measured. So every variable can be categorized as either nominal, ordinal, or interval ratio level of measurement. And depending upon the answers or the outcomes of a particular variable, that's what determines whether it's nominal, ordinal, or interval. Okay, so first ones are nominal. For nominal variables, these are outcomes that can only be placed in unranked categories. So there's a couple of characteristics of these. The first is that they are mutually exclusive. Mutually exclusive means that you are in one category or the other. You can't select multiple categories, right? And categorical variable means that there's a limited or fixed number of options available as your responses. So for example, what is your gender? If as a survey item, it is saying, what is your gender, and gives male, female, trans, male to female, trans, female to male, you're being given a set number of categories, and these are mutually exclusive. Mutually exclusive means it can be one category or the other. It can't be both categories. Neighborhood you live in is a great example for illustrating what is meant by mutually exclusive. So if you have a survey that says, what neighborhood do you live in? It's impossible for somebody to live in both Point Breeze and Chestnut Hill. You live in one or the other, right? So mutually exclusive means that you have one category to pick. You can't pick multiple categories. Okay, so nominal level variables are mutually exclusive. Political affiliation is another example of nominal variables. What's also important about nominal variables is that they are in unranked categories. Unranked means that if I gave somebody a list of all of the categories, like hair color, and all of the categories are brown, black, blonde, gray, and other, not everyone would put those in the same order, right? There's not some logical high to low, low to high order that comes from this. So that if there's a variable that has mutually exclusive categories, but those categories are unranked, there's not some logical high to low, low to high, that's how you know that's a nominal variable. Another option for scale of measurement is that some variables can be ordinal level variables. Ordinal level variables are also mutually exclusive categories, but these categories can be rank ordered in some logical fashion. So that if there's, for example, one of the examples from our class survey was on how would you categorize the socioeconomic status of your family, with the categories being listed as low, middle, and upper class. Obviously, there's some high to low, low to high ability to rank those, right? If I gave somebody a list of those categories, nobody's going to put, for example, middle first and high at the end, right? That there's some logical ranking for those categories. Same thing for some of our other options, like how confident do you feel in the police to prevent crime? They had a logical ranking, right? One of the options, the first option was, I think, not at all. The next one was a little bit, a moderate amount, a good deal, a great deal, right? So that there's this level of agreement from either strongly agree to strongly disagree that has some logical order to it, right? That there's some greater than to less than type of order. So ordinal variables have these mutually exclusive categories. They can be rank ordered, but the thing ordinal variables do not have is that we cannot measure the exact distance or range between categories, right? So we can't say, for example, with this example down here, how satisfied are you with your service? We can't use a number value to say somebody who answered very unsatisfied is 2 more times higher than somebody who answered neutral, right? We're not identifying some quantitative value for these, that these are categorical options that go in some ranked order, but we don't know the exact distance or range between those categories. And I think this idea of measuring distance between categories makes more sense once we cover what these interval level variables are. So an interval level variable is one in which outcomes are based on some underlying continuum that makes it possible to speak about how much greater one outcome is than another. Ratio variables are the same exact thing as an interval level variable, except 0 is a possible response. For our purposes, we'll just talk about interval level variables. I want you to know that ratio level variables exist. The only difference is that a ratio variable has 0 as a possible category. So that these are quantitative variables. Essentially, anytime a variable has a number value as one of the choices, that's an interval level variable. So for example, the class survey question on how much money do you spend on an average night out with friends? That's an interval level variable. It's mutually exclusive categories, right? You're either spend $50 or you spend $200. You can't be both. These can be rank ordered, right? From low to high, somebody who spends a lot of money on a night out to a little bit of money. And we can measure the distance between each category. That's what makes it interval. Somebody who spends $200 on a night out spends $150 more than the person who spends $50. So anytime there's a variable that has a numeric value as one of the outcomes, that's how you know it's an interval level variable. And again, I want you to know that ratio exists, but for our purposes, we're going to keep it simple for the semester. And oftentimes you'll see them referred to as interval ratio level variables. The text uses a lot. This just means that it's a variable that has a quantitative value, that it's not this categorical variable like nominal and ordinal level variables, but there is a numeric value as the answers. What's important to think about here is that what are the advantages or disadvantages or limitations of different levels of measurement? And interval ratio variables are the most precise. They have the most detailed types of data. So perhaps you could ask, what is somebody's socioeconomic status, and have this be as an ordinal level variable like we did in our class survey, right? We cannot, though, if somebody answers middle class and somebody else answers upper class, we can't say, for example, what's the numeric value, the financial difference, the monetary difference between those two categories, right? It's just a word to label low, medium, or low, middle, and upper. However, if we asked instead, one of the most commonly used measures for socioeconomic status is annual income. If instead we asked, what is your household annual income? This is now an interval level variable because we can quantify or measure the exact distance between different people's responses, between categories. One household income that is $100,000 a year is $50,000 more than a household income that's $50,000 a year, right? So it's always better to have more information in these ways. You can always make a interval level variable into a nominal or an ordinal level variable, but you can't go in the opposite direction. What I mean by this is, if, for example, we had the question that is just like on our class survey, what is your family socioeconomic status? And it's low, middle, or upper as the categories. We can't extrapolate from that to say people in our class who identify as lower class have household incomes ranging from blank to blank, right? We don't know that. We don't know what numbers people associate with that. However, if we had a question that asked, what is your family's annual household income? And they gave a numeric value, this would be our interval level variable. And from that, we could always then create categories, right? We can say anybody who answered 0 to 30 is low class. Anybody who answered 31 to 75 is middle class. Anyone who answered 76 and above is upper class, right? We can turn an interval level variable into an ordinal level variable that way, but we can't go in the reverse direction. Okay. Why should you care? Why is this so important for levels of measurement? This matters because it influences the type of statistical analysis that you can do with the variables. When we start chapter 2 and also in chapter 3, you'll see that for some types of descriptive statistics, you need to use one type of analysis if it's an interval level variable, or another type of analysis if it's a nominal or ordinal level variable. So this is one of these things that statistics is so different from other classes because the knowledge continues to build upon one another. So if you are confused at this point, it's okay. We're going to do lots of practice together right now in this lesson, and then you'll have more practice on the classwork problems as well, so that I hope by the time we do the practice now and the classwork problems, then you feel good by doing this for the homework. But my point is that do not just say, I'm really confused by this by the end of this week, and think that it's not going to matter for the rest of the semester, because being able to understand levels of measurement or scales of measurement and how to categorize different variables is going to influence your ability to do the next set of problems as well, right? That this all builds upon one another. Okay, so let's do some practice all together. So always, you'll see on the classwork too that this is how it's set up, is that I will say, I'll give you a certain variable, and I will say, what is the scale of measurement and why? Here is an opportunity for you to always use the same exact words for the why over and over again. Do not lose points because you are making up your own terminology, but that you can, not just can, but should, for every why, if it's nominal, write exactly what I have here, that they're mutually exclusive categories. You're welcome to abbreviate. I know that's long, MEC. What makes it a nominal variable is that they're mutually exclusive categories, but you can't rank them. What makes it an ordinal variable is that they're mutually exclusive categories and you can rank those categories, but we can't quantify or measure the distance between categories. And then lastly, what makes it an interval variable is that it's mutually exclusive categories, you can rank order them, and you can quantify or measure the distance between categories. So when you're giving the why, you're not just saying what are the characteristics of that particular variable, but for nominal and ordinal, you're also saying what makes it not the next one up, right? So nominal is not mutually exclusive categories. What makes it not ordinal is that we can't rank order. Ordinals, mutually exclusive categories, and can rank, let me start over, mutually exclusive categories and can rank order. What makes it not interval is that we can't quantify or measure the distance between categories. And then interval has all three of these characteristics. Okay, so I encourage you to take a minute and pause right now, right, for each of these 1, 2, 3, 4, 5, 6 different variables. If you think it's nominal, ordinal, or interval, with the practice writing out the why so that it's fresh and goes from your hand to your brain. And then I'll give the answers in just a moment. Okay, so hopefully you paused and you have a good guess at least for each of these. For IQ score, the answer for this one is interval. They're mutually exclusive categories, meaning that if somebody has an, I don't even know really what average IQ scores are, so this could be way off the scale of reasonableness. Let's say somebody has an IQ score of 150 and somebody else has an IQ score of 120. You can't have both of those, right? You're either a 150 or you're a 120. So that these are mutually exclusive categories. It's one or the other. We can rank order the categories from high to low, low to high, right? That if somebody has low IQ, somebody has high IQ, we're writing out all of the numbers in there's some logical order or ranking to these scores. And then the last characteristic of interval is that we can quantify or measure the distance between categories. We can say that for somebody who has an IQ score of 150, that's 10 points higher than somebody who has an IQ score of 140. So because there's numeric values that we can measure the distance between those values, that makes it interval. Second one here is type of drug. So with the categories being something like marijuana, cocaine, heroin, whatever. Types of drugs would be nominal. These are mutually exclusive categories. The drug is either one or the other, but we can't rank order them in some reasonable, logical fashion that everyone would agree upon, right? Sometimes students get confused upon the type of drug one and say, oh, well, I listed it as ordinal because people would say there's some drugs that are worse than others. Sure, that might be true, but would the vast majority of people, if you gave them a list of different types of substances, would they list them in exactly the same order? No, right? Some people might list cocaine higher than heroin and vice versa, etc. So that unless it's absolutely clear that there's some clear high to low, low to high, then it's not ordinal, it's nominal. Country of origin, where somebody was born. This one is also nominal. There's mutually exclusive categories. You're either born in the United States or you're born in France. You're either born in Canada or you're born in Mexico, right? You can't be born at two places at once. They're mutually exclusive categories, but we can't rank order them in any logical, obvious fashion. There's no obvious high to low, low to high that comes with the different countries' names. Number 4 is textbook price. This one is interval. There are mutually exclusive categories. One textbook costs $50, another costs $100. They can't, given textbook can't have two prices. You can rank order those categories, right? Some textbooks are expensive, some textbook prices are lower. And we can quantify the distance between categories, right? A textbook that costs $100 costs $50 more than a textbook that costs $50, right? That there's some way to measure the distance between categories. Then this last one is school, where the categories are listed as elementary, middle, or high school, so that students are picking if they're in elementary, middle, or high school. This one would be ordinal. There are mutually exclusive categories. Either you're in middle school or you're in high school or you're in elementary school. You can't be in both at once. We can rank these in some logical order, right? You start in elementary school, then you go to middle school, then you go to high school. But we can't measure the distance between those categories, right? We can't say how many years are there between elementary and middle, or between elementary and high school, because we don't know what year somebody is in within elementary or within middle, etc. So there's no obvious way to be able to quantify the distance between categories. A helpful cheat if you are stuck between, is it nominal and ordinal, or is it interval? If the values or the answers or the possible outcomes are a number, it's going to be interval. If they're a category, like a name, like elementary, middle, or high, or for the drug one, marijuana, cocaine, meth, heroin, then it's nominal or ordinal, right? The categorical variables are nominal and ordinal. The responses have names for the categories for the answers. Interval is the numeric values, the numbers for the answers. Okay, so that is it. This concludes lesson 1 on chapter 1 on types of data and variables. Next thing you should do is to go to the classwork 1 activity, spend some time, work through it on your own, and then you'll see that I have the answers to classwork 1 posted, as well as I will be posting a verbal recorded explanation of me talking through the classwork answers. And then as questions come up, if after you've done the classwork and looked at the answers and the recording for the answers, you have questions, then submit them on the Canvas discussion board place to ask your instructor, or send me an email. And as needed, we can set up a time this week for people to be on a live Zoom if you want to be able to ask questions live and in person with me. Okay, congrats on making it through the first lesson of the semester. Woohoo! All right, I will talk to you guys soon.